So as we start our questions, we're going to be using the mole plan. In step 1, we're going to find the moles. We now know 2 ways to do that. You can do that with a liquid, C times V, if I give you a concentration and a volume, or we've learned before, if I give you a mass, that says mass, you can figure out what 1 mole is, and then the molar mass. So the words mass and mass can cancel out, and you're left with moles. So step 1, find the moles. Step 2 is always a mole ratio, because we want to find the moles of the other substance. Where does that come from? It comes from a balanced equation. And then lastly, we're going to answer the problem. So there's probably 4 different questions we could do at this point. You could be asked to find a concentration. You could be asked to find a volume. You could be asked to find a mass. Or you could be asked to find molecules. So both of these are involving the box expression. So let's get to it here. So first question here, we need to do a total ionic equation. So we've got 3 things in the aqueous state here. So we need to start to break these up. So let's go ahead and do that. Our first compound is made of silver and nitrate. So let's put 2 silvers plus 2 nitrates. I'm going to write the 2 in a second here. My screen's been a little funny. 2 and 2. That's the first compound. The second one is magnesium chloride. So we've got magnesium and we've got chlorine. Magnesium's +2, chlorine's -1. Both are aqueous. Now, let's not forget that we've got a 2 here with the chlorine, so we better put a 2 in front. Our last compound is magnesium nitrate. It's made up of magnesium and nitrate. Magnesium's +2, nitrate's -1. They are both aqueous. Let's also not forget we've got 2 nitrates right there, so we'll put a little 2 in front. And I'm kind of out of room here, but I've got this 2 AgCls that haven't been canceled out. Or haven't been broken down because it's a solid. So since this question is double displacement, we should have 2 spectator ions. Nitrate seems to always be a spectator ion, and in this case magnesium is the other spectator ion. So what are we left with? We're left with 2 Ags in the aqueous state, and those 2 find 2 Cls in the aqueous state, and they make 2 AgCls in the solid state. And we've also got 2 NO3 -1s aqueous and Mg +2 aqueous as our spec ions. Great. Now that we've done that, we can proceed to our first question, which is asking us to determine the volume, V for volume, and molarity is a concentration if we have 25 grams. So as soon as you see grams, you should think to yourself, when in doubt, find the moles. So this is going to be our first step. So we're going to find the moles of silver nitrate. And then we're going to do some stuff with magnesium nitrate. So we don't care about that compound, and we don't care about that compound for this question. They're not involved. So let's go back and let's find the moles from our 25 grams. So moles of, this is silver nitrate, equals 25 grams of silver nitrate, X in a line. So we need to think to ourselves, box expression. We've got 1 mole of AgNO3 up top, and our molar mass, which is 169.87 grams of AgNO3. That's all that stuff added up. Cancel, cancel, and the number you should get here is 0.147. So that's our moles of silver nitrate. Step 2, we want to get the moles of the other substance. The other substance is magnesium nitrate, so let's do that. Moles of MgNO3 bracket 2, O2, equals 0.147. All right, we carry our number along. That's moles of silver nitrate, X in a line. Now, boxed expression, not boxed expression, balanced equation. We've got a 2 in front, and we've got a 1 in front. So those are the numbers we're going to need. So I'm going to put the 2 moles of AgNO3 on the bottom, so they cancel out, and then 1 mole of Mg bracket NO3 2 up top. Do the math there, you get 0.07358. So we're going to need to carry that number into our final part. So remember it. Step 3 is asking us to find the volume. So what's our volume formula? That's our volume formula. We just found the moles. 7, 3, 5, 8. And the concentration is given right there in our question. And so we actually end up sort of with that number from earlier. It's a volume. Volumes are measured in liters because our concentration is in moles per liter. You could switch that to 147 mils if you want, but we don't need to do that. And that wraps up question 1. Okay, actually we've got 1C as well here to answer. So let's see, what are we doing in this question? We're determining the concentration given 25 mils. So determine the concentration of magnesium. 25 mils reacts completely with Avogadro's number here. So we've got a volume. Alright, so molecules. That's Avogadro's number, like I just said. So that's going to be our starting point. We're going to find the moles of the silver nitrate using Avogadro's number. So let's do that. Moles of AgNO3 equals 3.54 times 10 to the 23. This is molecules of AgNO3. Now, this is coming from the box expression. I got molecules up top, so I better put Avogadro down below. Molecules. We can cancel. And if I've got that many molecules, it's because I have 1 mole of this AgNO3 stuff. So you do a little computation, and you should find that we get 0.588 moles of AgNO3. So step 2. The other part is about magnesium chloride. So we want to find the moles of MgCl2. We'll carry along our number. That's moles of AgNO3. X in a line. So box expression. We've got a 1 in front of that, and we've got a 2 in front of that. So we need a 1 and a 2. So it looks like I need my 2 moles of AgNO3 on the bottom. Cancel. And my 1 mole of MgCl2 up top. So we're just going to sort of divide that number by 2, I guess, and we get about 0.29. Let's carry that into our final step here. Again, the question is asking us to find the concentration. N over V. We just found the N. It was 0.29. The V is given as 25, which we divide that by 1,000 and get 0.025. And you divide those two numbers and you get 11.76. It's a concentration, so that's big M. So that's a seriously strong concentration. And that's fine. Okay, so this question is again asking us to write our total net ionic equation. So we've only got 2 aqueouses in this question, so let's proceed. We've got 3 silvers in the aqueous state, plus 3 nitrates in the aqueous state, plus the aluminum is the solid. We're not going to change that. And then we've got to break up aluminum nitrate. So we've got 1 aluminum that's plus 3, and we have 3 NO3s that are minus 1. And then we've got our 3 silvers. So 3Ag is solid silver. Don't break it up. Now the only thing we have in common here, because of single displacement, will be our nitrates. So what's left over? Well, we have 3 Ags in the aqueous state. And those find 3 aluminums that are solid. And the aluminums liberate themselves and are now floating in solution. And then we end up with 3 silvers. And we also have NO3 minus 1 aqueous as spec ion. And that's 2A. On to 2B here. We're going to determine the mass of silver that can be produced from 50 mils of 0.2 molar. So as soon as I see this stuff, I'm thinking that is a volume and that's a concentration and that's my starting point. So let's do that. N equals C times V. Let's plug our numbers in. 0.2. And when it comes to 50, I convert that to liters by dividing by 1,000. So 0.05. And let's multiply, we get 0.01. And that is moles of, what is it moles of? It's moles of silver nitrate. AgNO3. Continuing on, we want the moles of silver. Moles of Ag equals, let's carry our number along. Moles of AgNO3. X in a line. So now we need our balanced equation. So with their silvers, we've got a 3 in front of the silver nitrate, and we've got a 3 in front of the silver. So it's not going to change our number, moles, but it'll change the words. So AgNO3 on the bottom, cancel, cancel. 3 moles of Ag up top, 0.1 moles of Ag. So we're just about done this question. Last thing it's asking us is just to find the mass of silver. So that would be step 3. We want the grams of Ag, knowing we have this many moles of Ag. So box expression. What does a mole of silver weigh? Should weigh about 107.87 grams. Cancel, cancel. Multiply, 1.008. And that should wrap up 2B. So now some panic might set in because we're seeing the words limiting reagent and we're probably moaning. But what did we learn in the last unit? We learned to forget about the mass of one thing and recalculate. Well, that's what we're going to do here. We've got a mass. We're going to forget about this 0.1. We could forget about the volume, but we're not going to do that. So let's forget about the 0.1 grams of aluminum and let's find the moles of silver nitrate because, well, that's what we can do in step 1. N equals C times V. So our concentration is 0.25. Our volume is 150 or 0.15. So when we multiply those two values together, we should get 0.375. And what is that? That's moles of silver nitrate, AgNO3. This question is now about aluminum, so that's what we want the moles of in step 2. Moles of aluminum equals the number we just found that's on our calculator. Don't clear it away. Moles of silver nitrate, X in a line. So, up to the box expression. We've got a 3 in front of the silver nitrate, and we got a 1 in front of the aluminum. I should also point out again, kids, this is a limiting reagent question. It has nothing at the starting point to do with our products. It has everything to do with our 2 reactants. So, let's fill the numbers in. 3 moles of AgNO3 there, 1 mole of aluminum up top. So you do the math on that one, and you get 0.0125 moles of aluminum. Let's finish this question off because we want to find the grams of aluminum. So let's do that. 3 grams of Al, knowing we have 0.0125 moles of Al. X in a line. Boxed expression time. 1 mole of aluminum. What does that weigh? 26.98 grams of aluminum. Right from the periodic table. Cancel, cancel, and we get an answer of 0.34. What do we need this for? Well, we need to make a comparison now because in this question we need 0.34 grams of aluminum. We have what is in the question, which is 0.1. So we need $34. We have $1. We don't have enough. So we can conclude that aluminum is the limiting reagent. And we know we need to use limiting reagents to go ahead and solve problems. So what's this problem actually asking us to do? Well, it's actually asking the mass of silver. It wants to know how much silver is produced from our limiting reagent, which is this one. This is just a solid-to-solid question. We can do this like we did in Unit 2 with 3 steps all compacted together. So the question is asking us to get the grams of silver, knowing we start with 0.1 grams of aluminum, 3 steps. Step 1 is from our boxed expression. It says if we have 1 mole of aluminum, it should weigh 26.98 grams of aluminum. We kind of just used those numbers, didn't we? Cancel, cancel. Next step is a mole ratio. Well, what mole ratio we got here? We've got a 1 in front of aluminum and a 3 in front of silver. So let's add that in. 1 mole of aluminum, 3 moles of silver. Cancel, cancel. Last step is box expression. We got 1 mole of silver, and we figure out what it weighs, and it's 107.87, and that's grams. And so when you multiply all that together, you get 1.125, and that is your answer. That's the mass of silver produced in this particular question. Alright, so in this question we're actually going to be able to knock out parts A and B together because in part A we're just creating our balanced equation. It's double displacement. We've got silver nitrate, which again seems to be in every question, and that's aqueous, plus magnesium bromide, also aqueous, So we'll switch the magnesium with the silver, giving us silver bromide and magnesium nitrate, AQ solid. A little bit of balancing because we've got 2 nitrates, we've got 2 silver, there we go. So that one is balanced. And then on to our net ionic equation stuff. So we've got 2 silvers in the aqueous state, and we have 2 nitrates in the aqueous state, plus magnesium plus 2 aqueous plus 2 bromines. That's not a good plus sign. Aqueous. Arrow. We'll leave the 2 AgBrs untouched. And then lastly, we've got the magnesium plus 2 aqueous and 2 nitrates. Being its double displacement, we should have a couple of things that are the same. The nitrates are the same. The magnesiums are the same. So in the end here, we have 2 silvers in solution, and they find 2 bromines in solution, and they make 2 AgBrs. Probably no surprise there. And let's not forget about our spectator ions, 2 NO3 minus 1 and Mg plus 2. Our spec ions. Good. So, as we roll into part C, we might realize that we need a balanced equation. So we've made a balanced equation here, so I'm just going to take a second to steal this balanced equation and add it to my next part here. Like so, looks perfect. And now we're going to go ahead and answer this question. So it's asking us to determine the molecules. So it sounds like we're ending with Avogadro. And we've got that many milliliters and concentration. So right there I'm seeing I can find the moles of silver nitrate because it's a liquid. So that's what we'll start with. N equals C times V for silver nitrate. We've got 0.45 for concentration. And we've got a volume of 0.05 because we're going to switch that into liters. So we're going to multiply those two values together and get 0.0225, and that's moles of, what is it moles of? It looks like it's moles of silver nitrate. I'd like to write that at this point. Next step, I want to get the moles of the other substance. The other substance in this question is, it's saying the precipitate. Well, what substance is the precipitate? Well, that substance is the precipitate. So I'm simply asking how many molecules of that are created in a fancy way. So first we'll have to get the moles of that substance, AgBr. So let's carry along our number 225 moles of AgNO3. I wrote really big, I don't know why. We need our mole ratio, and it looks like we've got a mole ratio of 2 and 2. So once again, our numbers aren't going to change, but our substance will. So that's silver nitrate, might be a little hard to read. And then on the top here, we've got 2 moles of AgBr. So we've got the same number. So now we need to finish this one off here. I'll make a little bit of room. What is this asking us to find? It's asking us to find the molecules. So it sounds like Avogadro's involved. So we want to get the molecules of AgBr, because that's the precipitate, knowing we have this many moles. Oh, that's a 5. Moles of AgBr, X in a line. And I would think we've got moles up top, so we should put 1 mole of AgBr on the bottom. It's Avogadro up top. Cancel, cancel. And we're going to have to jam this in here, but we should get 1.355 times 10 to the 23 molecules. Hopefully you can see that there. And that wraps up the homework.